Hello and welcome to the 2025 K-State Garden Hour webinar series. We are so glad that you are here. This webinar series started in 2020 and has been a collaboration of the entire K-State Horticulture Extension team. Since the start of the program, we have reached over 83,000 gardeners just like you. We are pleased to continue offering the K-State Garden Hour series for free. If you have enjoyed these educational webinars, please consider making a tax-deductible donation to support the program. The link to donate can be found in the chat or on our K-State Garden Hour website. This webinar is hosted by K-State Research and Extension. My name is Calla Edwards, and I am the Horticulture Extension Agent for Butler County, located in El Dorado. Everyone involved in the development of this series is an extension professional for K-State. Most of us have a background in horticultural education or a related discipline, but most of all, we each have a love for educating and sharing important gardening topics. Before we get started, just a couple housekeeping notes to cover. Please use the Q&A feature for questions related to the presentation. This is where we'll look for questions at the end of the webinar during the Q&A sessions. You should be able to see a button along the bottom tab that says Q&A. Just click on it and you'll be able to enter your question. Today's webinar will be recorded and we will post it to our K-State Garden Hour website. We also typically upload the additional resources related to each topic and the ones that were shared through the chat. Our website will also be where you can access previous topics and upcoming webinars in the series. Our moderators today are Annie Baker and Lane Weens. They will be sharing information through the chat during the presentation. They will also help us facilitate the Q&A portion of the webinar. Today's topic is heat-loving perennials for Kansas. I am pleased to introduce our speaker today, Jason Graves. Please give us a few minutes as we transition before the presentation starts.
Okay, hopefully that's all working now. I think we're ready to start. Got the screen share. Yeah, welcome everyone to the May Garden Hour. We're excited to talk about some heat-loving perennials here over the noon hour. Hopefully you've been dreaming of spring and fun to see some of those ideas coming through the chat of perennials people are interested in planting. Maybe you can grab a couple other ideas today. We're going to cover some plants here as we go through with a little bit of information first. So I'm Jason Graves, horticulture agent here in Central Kansas District, covering Salina and Ottawa counties. And we certainly get a lot of heat here in our area of the state, like many of you experience. And I'm sure we're anticipating as we get closer to summer, we're going to be dealing with that heat. So this is timely information. So here are our objectives today. I just want to, three kind of overarching objectives we're going to do as we go through this. Just want to talk a little bit about understanding heat impacts because, of course, heat impacts our plants in different ways. So it's good to be aware of those different issues. We want to talk a little bit about heat proofing your landscape. So we'll share just some practical reminders there. And we'll talk about promoting plant resilience as well, things to consider as far as resilience with our plantings. And then we'll cover some heat-tolerant perennials. So that's kind of the outline of where we're headed. So we're going to jump in here and talk first about the plant heat zone map. So this is American AHS, American Horticulture Society Plant Heat Zone Map. So many of you may have seen this. If you haven't, you can look it up online. This is kind of an indicator of what we can expect with some of the heat across the country, and specifically here in Kansas, you can pinpoint as you look at that map. This gauges how many days per year we can be on average reaching temperatures higher than 86 degrees. And that 86 degrees is basically what, agronomists, horticulturists kind of agree is the temperature at which growth starts to decrease in a lot of our plants, especially our C3 photosynthesis plants. And so obviously, the longer the duration of high heat, the more significant the impacts on our plants. A day or two of high heat is different than, a string of a heat wave, and will have different effects. So in Kansas, you can see we have as many as 60 to 120 days a year where we can be reaching temperatures that kind of push that upper limit of what plants, really prefer. And so that map may be useful as you're shopping, thinking about plants, and just thinking about plants for heat tolerance. When we talk about heat impacts on plants because of those temperatures that often reach higher than 86 degrees, one of the higher the temperature goes, we have more slowdown in the growth and the photosynthesis of our plants. And so obviously most plants grow best between 60 and 86 degrees. And as we get to temperatures over 90 for longer periods, that growth starts to slow down, and we'll start to see signs of stress on our plantings. Typically, if we get over 104 degrees, our plants may survive but show signs of stress. And it's going to depend, there's other factors that'll impact how much stress we're going to see, such as drought or wind or other things, and how long that heat lasts. But the bottom line is that high temperature slows down chemical activity and growth in our plants. So what are we going to see when that happens? Well, we're going to see anything from leaf rolling to leaf cupping. We're going to see wilting. We might see scorch, blossom, and fruit drop on crops. We might see bolting on cool season crops. We'll see even things like sun scald on our woody trees and some ornamentals and plants like that as well. So I've got a picture here. We're gonna talk a little bit about a few examples of these. So this is an example of one of those, I guess, adaptations that we might see when heat strikes in the garden. So you may have seen this on your tomato at one time or another during high heat. This was a picture I took in August of 23 when we had extreme heat. And you're seeing the tomatoes rolling up their leaves. And basically, plants have an ability to change the angle or the morphology of their leaves to limit exposure to the sun and to limit water loss. So you'll see this on, where corn plants will roll their leaves into a cylinder. Soybean leaves will even flip their leaves upside down. So the lighter bottom surface is facing up to try and reflect that heat. So there's different ways that plants will try to cope with this. But of course, this impacts photosynthesis because we're not photosynthesizing near as much under these conditions. And so the longer it lasts, the more stress accumulates. So wilting is a common issue. You're going to see plants wilting down. Probably seen that in your garden. As the heat hits, one of the strategies to reduce that surface area to allow less heat to build up is for that leaf to wilt down. And so you can see that on crops in the garden at times. And then as temperatures cool, those leaves will kind of reset. Back in 23, as I'd mentioned earlier, we also get things like sun scald. And so sun scald can happen in different settings. In the garden, you may see things like this on a tomato or a cucumber where it's just sunburned, basically. And that is pretty frustrating. When we, come into the harvest season, if we get a hot streak of weather, sometimes it can damage the fruit on our crops. This was the heat wave I'm referring to back in 2023. At least here in Salina, we were kind of hitting high temperature records almost every day for a few days. And this heat wave was pretty intense back at that particular time, and really across Kansas. We were having pretty dramatic heat indexes as well, up to 130 in some cases in Kansas during this time period. So we're no strangers to heat here in Kansas, and we certainly do get the extremes of that. One of the things that heat really does is it actually can make cell membranes in our plants too fluid, and we get leakage, we get disruption of some of the enzymes and proteins and things. And as things like that go wrong, we just start to see a lot more damage on our plants. So we get cases, we were seeing things like this as the summer went on that year, where we're getting a lot of scorch, even on hardy oak trees that are normally very resilient. We're seeing, a lot of heat scorch on those leaves as they've been damaged due to that high heat. We're seeing, just the effects of that heat are usually pretty dramatic when we get temperatures that hot. So, sun scald, as I had mentioned, is one other potential problem we can run into, called south or southwest injury on trees, and this can happen in high heat waves as well. And so if you have thin or young young trees with young bark, some protection and shade on that bark until it gets corky is a good idea, because you can see on this maple tree, simply the high heat was too much and kind of cooked that south sides. So, things to keep in mind. One, as we had mentioned, heat really slows chemical activity, and that's one of the main, I guess, issue we run into in these events of where we have heat waves. And a lot of times that means plants, especially C3 plants, are having to adjust to that by limiting their water loss. And the way they do that is by closing the stomates on the leaf. And you can see here on this slide where I've circled the guard cells and the stomate here, where normally we have a lot of gas exchange going on. And what happens is, in high heat waves, plants need to close that a lot of times to limit water loss. But at the same time, what happens is we end up shutting down that photosynthesis that the plant needs to continue to make food. And so we end up a lot of times with a situation called photorespiration, which is actually a buildup of oxygen on the inside of the leaf. And the enzymes that normally are working to capture and fix carbon dioxide are grabbing oxygen instead. And what that leads to is basically a waste of energy. And so plants can actually start to use up more food than they're creating when we have high heat situations. And you can see here that this picture from the U.S. Botanic Garden kind of highlights, you can see highlighted there some of the closed stomates. And so that's what those would appear. Normally they'd be open, under cooler temperatures, allowing that carbon dioxide and oxygen exchange to happen. And so under stress, the plant closes those, and then we run into photorespiration, which is a wasteful process where the plant can use up more food than it makes. So photosynthesis in a typical day, obviously, should be more than respiration. Respiration is the usage of the energy that plants are making. And so what we know is that in heat, respiration is still very rapid. And here in Kansas, we can have a lot of hot nights during the summer. And one of the things that especially hot nighttime temperatures lead to is that very situation where plants may start consuming more energy than they are creating due to that photorespiration. And so a lot of times we may find that our plants are struggling, especially because of the high nighttime temperatures. Okay, so let's talk about some practical things here for heat proofing and what can we do in our landscapes to keep in mind as we approach the summer temperatures. So one of the things, obviously, deep watering, we, as an extension agent, we talk about this all the time, deep infrequent watering being an important strategy when it comes to heat proofing our plants, knowing our plants' roots as well. And so we're going to kind of run through this list and tackle these topics here fairly quickly. So when we talk about deep infrequent watering, we want to water with a purpose, and that means deep infrequent applications of water to the depth of the root zone that our plants are growing. And that means avoiding watering every day, especially here in the springtime, where we really need our plants to start growing big, deep root systems as deep as they can to prepare for that summer heat. So we call that, kind of allowing those mini droughts between waterings, allowing that soil to dry out thoroughly. And so that way we promote deeper root growth and prepare for longer droughts. So allowing plants to experience some stress and not watering shallow, frequent applications that are going to encourage surface rooting. That purpose of watering, obviously, we prefer to water early in the morning to reduce the evaporation and decrease disease issues on our plants. And obviously, we encourage and recommend skipping the watering after the rainfall because that's just unneeded. So be sure to pay attention to sprinkler systems and irrigation clocks, after rain events, and be sure they're turned off or have a rain sensor. We also prefer, like I said, watering less in spring and fall when those plants shouldn't be needing that extra water, and watering what the soil can absorb, because a lot of times our clay soil is it can take time for water to absorb into it. So we sometimes have to water slowly in order to get that water into that root zone. So sandy soil can take water in at up to a rate of 2 inches per hour, where clay soil may only take water in at up to a 1/4 inch per hour. So that's a significant difference in how long we're going to have to water to get that water to absorb into the clay soil. Mulching, of course, is one of the huge practical tips that we can use as far as promoting heat resilience in our landscapes. Obviously, one of the big advantages is keeping that root system cool on our plants. Bare soil, as you can see here in this slide, is going to be much, much hotter than soil under mulch. And so just a reminder on that under the mulches, we significantly reduce the temperature of the soil. Even with a small layer of mulch, just an 1.5 to 2 inches thick, will reduce that temperature. And so bare soil, we know, is going to lose water through evaporation much more quickly as well. And so obviously the benefits of mulch are going to be very valuable as we prepare our plants to deal with heat. Weeding, not a popular thing, not something we always like to do, but certainly we know that weeds compete for water and also can increase the evapotranspiration of the soils we're working with as much as 25% in just a summer day. So we can lose, a significant amount of water just through weeds in our landscapes and gardens. And so if we can reduce the competition from weeds, we can also reduce the water use of those weeds and reduce the evapotranspiration of that soil, so more water is available for the plants that we are intending to grow. Now, when it comes to heat, one of the things we do recommend is pausing fertilization in those periods of high heat, because we don't really want to induce new growth during a heat wave. That's not an ideal time, obviously, to be pushing plants to grow. And so it's much more it's recommended to wait until a cooler period arrives to fertilize if needed. Generally, plants are prioritizing cooling during heat stress and really diverting resources away from nutrient absorption. So they're really just in survival mode and prioritizing cooling. And fertilization just is going to be is not recommended during high heat waves, especially. Pruning is one thing, recommendation that a lot of times is not recommended during heat either, just because of the fact that a lot of times, especially on trees, shrubs, things like this, we open up a new part of the plant to sunlight where it was previously shaded, so we run into that sun scald potential. So timing your pruning in the optimal times of year is recommended. Obviously, if we stress out those plants, they're also more likely to attract pathogens, insects, things like that. Open wounds are not great during times of heat and stress. So if we can prune correctly, we can avoid having some of those stress responses. One of the things, a little aside here, this is really why lion tailing is such a problematic way of pruning trees. And so you see this, I've been seeing this occasionally, and trying to recommend folks avoid this when they prune, because typically on the hot days, especially in the heat waves of summer, our trees are actually using the interior leaves to photosynthesize and create sugars, because those leaves are shaded and cooler. And so this style of pruning actually removes all of those inner leaves, as you can see here in the picture. And so lion tailing really sets a tree up for stress, because it removes those inner leaves that are shaded and would be providing photosynthesis during those times of heat. So we recommend avoiding this type of pruning on trees for that reason. Chemical applications can be an issue in heat as well. I've run into this actually myself. When you make an application on a plant in the summer heat, a lot of times you can get phytotoxicity, which is sort of a burning or just a scorching on the plant leaf that you applied the product to. And so that is something to be very aware of during a heat wave, is checking labels for temperature information, because a lot of labels on products will have temperature limits, as far as when they can be applied. And so we want to abide by that, because otherwise we run into, more stress on our plants when we have this phytotoxicity problem. So as finishing up and looking ahead here to some resilience, we've covered a lot of practical, I think common sense tips that you all probably are familiar with. I also want to talk a little bit just about heat proofing and promoting resilience. And one of the things that we're learning more and more about resilience in our plantings is how important the soil is to our plants in becoming resilient to heat and to stress. So I've got this slide here where we're going to just discuss a little bit about promoting resilience and why healthy soil is really such a key part of resilience in our plantings. The soil health aspect is critical, and if we can address that and build soil health in our landscapes, we're going to have much more heat resilient plants. As most of you know, Kansas here, this is just a general map that kind of shows that Kansas is a mosaic of prairie landscapes. So that's the habitat we are living in, basically transitioning from, tall grass prairie in the eastern part of our state to the mixed and short grass here in the center where we are. And then, you've got shorter grass prairies in the west. And, prairies historically were dominated by grasses for a good reason. We're going to discuss why that is. The grasses across our state have adapted and have unique ways of dealing with heat. And that's why they thrive here. And so the tall grass prairie is kind of our example as to what we can do as far as our gardens and landscapes. And we need to kind of remember that as we plan for heat resilience. One of the things, that's unfortunate is the loss of some of that habitat. And you can see here the changes, because we've only got about 4% of that ecosystem left intact. We've had a lot of development. And so it's easy to forget that here in Kansas, we have historically an environment that is very resilient to heat. If we take time to understand the prairie ecosystem that we live in. And so this picture comes from one of our landscape design trainings, where we talk about the all-American landscape. But when I look at this picture, I see here in Kansas, at least when I look at this picture, I see a landscape without a sense of place. And what we're learning, as we go more and more, as we develop our skills more and more as gardeners, is we're learning to embrace the place that we live in, right? And here in Kansas, that's a prairie. And so we don't want to forget that is the ecosystem that we live in. And so as we think about our own landscapes, we want to think about what makes the prairie so resilient, because as you look at out there, these are the plants that have historically been here and survived and thrived. And so resilience really is pretty remarkable in our prairie climate. And prairie environments here, like we're in, are known for intense weather fluctuations, known for droughts, for wind, for heat, and for cold. And these plants are built to endure those conditions. And so obviously there's kind of a community-based growth pattern that these plants have where each plant is drawing moisture from different zones in the soil. The prairie ecosystem is very crowded and competitive, and these plants have found a way to thrive in this environment. And there's a lot of adaptations they have, some of which we'll discuss here shortly. So soil, though, is a key part of that ecosystem. So I want to reiterate this idea of soil health, because below the prairie, below that tall grass, mixed grass, short grass prairies, is another kind of ecosystem that gardeners, as we develop, need to become familiar with. I call this climate resilient soil. And you can see here in this photograph, what we're trying to highlight and illustrate is all the places where microbes live in the soil. And microbes, the microbial life of the soil, or the rhizobiome, is what I call the hidden helpers in the soil. These are the resident microorganisms that move in tandem with the plants and create a whole ecosystem below ground. We know that plants are recruiting microbes in our prairie soils that are helping them become more stress resilient. And really, we're just beginning to understand all the connections that exist. But what we do know is that the rhizobiome in the soil helps boost drought resistance in our plants. It creates more access to water for our plants. There are microbes that can alter hormone levels in plants. There are microbes that can activate heat proteins in our plants, and just in general help our plants cope with stress. And so the healthier our soil is, obviously the more stress resilient our plants are going to be. In the prairie in the root systems of our prairie plants, basically we know that those plants have recruited microbes historically, and when they're under stress, especially, those microbes are enlisted to assist with that stress. So as an example, you can see here this ectomycorrhizal fungi. So fungi is one microorganism that we'll see that forms mutualistic relationships with our plants. And you can see in this seedling, this is a pine seedling example, but in this example, the mycorrhizal fungi is the pure white, the white kind of rooting that you see in there. The pine tree has the kind of off-white root, but you can see how much more of the soil the plant can access just by having this association with a beneficial fungi. And in the prairie, we have AMF fungi. We have a number of different species just like this that are connected to our plant roots that are doing the exact same thing. And so the more life we can grow in our soil, the more resilient our plants are going to be. And so we know that these microbial communities and the soil ecosystem is a big part of creating resilient plantings and heat-tolerant plantings. So all that to say, the bottom line is we need to create that ecosystem, and one of the best ways we can do that is with organic matter. The soil organic matter found in the areas that we're planting is going to be the foundation for that productive soil, positively impacting every other soil property. Specifically, the organic matter is really the food and shelter for that microbial life. It's kind of the bottom of the food chain, so to speak, in the soil. And so we want to be sure we're doing practices that increase and maintain organic matter as we go about our gardening endeavors. It really takes a village to make a soil function, as I've heard it said. But obviously, there's a lot of things that organic matter creates. It builds that microbial life. We get more nutrient cycling. We get soil aggregates. And so we just get a much more robust plant when we increase our soil health. So really, the time for gardeners, the practicality of this is the amending of soil. And, whether we do soil testing to kind of diagnose some properties of soil. But bottom line is that you can improve your ecosystem in your soil with organic matter. And so we have a lot of options, whether it's compost, shredded leaves, cover crops, a lot of ways we can improve our soils to increase that resilience. And so uh, this slide is just kind of a funny, I guess, reminder. The bottom line here is the 4 ways to improve Kansas soils are to use organic matter, right? And we preach that an awful lot. So continue to, find creative ways in your gardens to build that organic matter, whether it's with the organic mulching, whether if it's a new planting, obviously we can work in that organic matter even before planting. But bottom line is we want to build that soil ecosystem because it is helping our plants be stress resilient. Okay, so now we're on to some of the more fun pieces here, the plant part, right? So we're talking about promoting resilience. Obviously, if that soil ecosystem is working and healthy, we're going to have resilient plants. But we also have to take the step of choosing the plants that are known to be heat tolerant, that are native to this environment, or at least an environment that they can tolerate the heat that we deal with. So we recommend choosing a diversity of plants, native and adapted, that can handle, the stress that they're going to encounter. And of course, maintaining those smartly. We've already kind of gone through some of the tips for that. So we know that biodiversity above ground creates biodiversity below ground as well. And so that's a thing to remember as we go through these plants that we're going to look at, is that as we include more of a biodiverse planting, we're going to build more and more life in our soils. Each one of those plants draws a new set of microbes, and so enlisting more and more microbial life in our soil as we add diversity. So obviously, the practical side of this is choosing heat-tolerant plants. And some plants are just better, frankly, at dealing with heat because they have adaptations. And those adaptations can come in 2 different forms. It can come in the form of photosynthesis, the way they do photosynthesis, or it can come in morphology, the form and structure of the plant. And so when we're talking about adaptations in photosynthesis, these are the 3 main types of photosynthesis that we encounter in the plants that we can choose from. We've got C3 plants, which are most common, cool season plants that exchange gases like the CO2, carbon dioxide, through open stomates. And they do well in lower average temperatures, but when the temperatures go up, they have to close those stomates. And so we run into photorespiration. So C3 plants can have some challenges when it comes to high heat. C4 plants they can actually continue to exchange gases through slightly open stomates and minimize water loss in the heat. It does take the plant some additional energy, but what it does is it avoids that photorespiration problem. So C4 plants often you'll see recommended as good for high heat environment. You'll also run into CAM photosynthesis, and that particular method of photosynthesis is plants that actually leave their stomates closed during the day. They do the gas exchanging at night. And so that avoids the water loss and also allows that plant to store water more effectively. And so we again avoid the photorespiration. And so the bottom line is these different adaptations that we have with the way plants photosynthesize can help us choose plants that are more tolerant of heat if we take time to understand that. The bottom line is for heat, these 2 methods of photosynthesis are really the best as far as high heat, if we're going to deal with high heat environments. C4 photosynthesis, and we have many examples of C4 plants. We talk about the prairie grasses that I mentioned earlier. These plants are C4 plants, and that is why they dominate in a prairie environment. They have those adaptations to exchange gases, to avoid photorespiration, and to grow in the heat, to continue to grow. We have CAM photosynthesis, and this is more common in things like our succulents that we will see here in a minute. You'll see some examples there of the prickly pear cactus, yucca, stone crops. These particular plants also avoid photorespiration by that adaptation of photosynthesis. So those are the two main categories to be aware of. We also have, aside from photosynthesis adaptations, we also have just morphology adaptations in the structures of plants. And so you'll see things in these plants like light-colored leaves. You'll see small, narrow leaves, thick leaves with waxy cuticles, a leaf orientation change. They may have leaf hairs or pubescence, deep root systems with a thick crown. We may have water storage abilities and stomate regulation differences. And so here you can see butterfly milkweed that's coming up out of the ground, which is a very heat tolerant plant, and the pubescence on that plant, and how the leaves there underneath, you can see all the hairs that coat those leaves and stems is kind of a way, that's a heat tolerance adaptation that allows that plant to tolerate a hot environment. And so these are adaptations that we'll see in our C3 plants that are here in the prairie that they use to actually adapt to the heat. And so if we choose those plants, we're going to get resilience. Okay, so we're finally to the fun part here. We're going to zoom through some plants and just mention a few of the adaptations that we can find in those. So heat-loving perennials for Kansas. This won't be exhaustive, but we will try to highlight a good number of plants here. One of the best plants for heat is our grasses, like we mentioned, because of the C4 photosynthesis. So they avoid the photorespiration. So these are at the top of the list. And really, this is just a plug for y'all to tune in, I guess, next month to our garden hour, because in June, that is our topic, to cover native and ornamental grasses. So that's a plug to come back in June and join us to learn more about these. But really at the top of the heat tolerant list is our grasses. And that is because of that adaptation in the photosynthesis, the way the plant does photosynthesis, the C4 pathway. Sedum is also going to be at the top of that list because it again has the CAM photosynthesis with has the properties to avoid photorespiration. And so this plant is common in a lot of landscapes. Our sedums are very drought and heat tolerant because of that CAM photosynthesis adaptation. Very pollinator friendly as well, great for those garden uses. So all kinds of varieties of sedum available to gardeners. This one's Autumn Joy that I've highlighted here. But we also have smaller varieties that the creeping sedums like blue spruce or sedum kampchaticum, which these both are smaller, lower growing varieties that can be used, more as a ground cover or a creeper. But these also have that CAM photosynthesis that allows them to survive in intense heat. If you're looking for a native that has CAM photosynthesis, this would be one you could look for, prairie fame flower, which is a plant that we've grown in our demo garden for some time with good success. Has a summer bloom, like I said, takes that heat and drought very, very well because of that ability it has to exchange gases at night. Yucca fits into this category as well when we're talking heat tolerance, and we do have some yucca that are a little more ornamental to choose from, such as Color Guard, which you see there in the lower right picture. There's some varieties that have some variegation and some different ornamental qualities to them. And so this is a good plant to consider for heat tolerance. You may not fit in every garden, depending on what your style is. But for xeric heat tolerant gardening, our yucca becomes a really good option for us because of that. Again, because of the CAM photosynthesis. Rattlesnake Master, this one is actually a C3 plant, but it has a number of adaptations that, as you'll see, it looks very much like a yucca, and that is part of the adaptation for this plant. It's got those tough, narrow, stiff, leathery leaves that reduce water loss, has a waxy coating on the leaves that helps preserve water. And it's almost got some C4 photosynthesis-like water efficiency. And it has even those tough leaves that are very resistant to wilting and things like this. So rattlesnake master is a great pollinator plant, very heat and drought tolerant. We can use this more in our gardens, to plan for heat because it does tolerate that condition well. Yarrow is a very common recommendation you'll see for heat tolerance simply because it is a plant that tolerates heat very well, both drought and heat. Great for pollinator gardens as well, but it's a C3 plant. And so it has these adaptations, though, that we've mentioned, especially in the leaves. And so you'll see on this next slide, I'm going to highlight some leaves just to look at the texture of some of these leaves because this is part of the C3. Some of these C3 plants have this adaptation to tolerate heat because of the way their leaves are structured. And so the adaptation they're using is either leaf shape, leaf color, or leaf covering. And so the finely divided leaves here, you see the picture on the left is Russian sage. The picture here on the top is the yarrow, and the smaller picture below is catmint. So these three plants are well known for heat tolerance, and you'll notice that they all have some similarities in the color. They have some fine texture to the leaves. Really, the color actually reflects sunlight and helps the plant stay cooler. They've got fine leaf hairs that reduce water loss and kind of create a barrier to moisture evaporation. And those leaf hairs can also reflect some of the sunlight. So these are the adaptations these plants are using as C3 plants to survive in the heat. Russian sage, as we just looked at, is therefore one of those plants that we always recommend in a hot heat list because it obviously has those adaptations. Even though it's a C3 plant, it comes with those narrow leaves and that lighter leaf color. It also has very aromatic foliage, some of these plants as well, you'll notice. And that even part of that is to help deter herbivores that would eat that foliage to help it conserve moisture. And so some of those oils are even defensive in that way. It's one more adaptation plants can use. So Russian sage, various varieties of this. We do have smaller, more compact varieties now that you can use in landscapes as well. So you do have to look and choose accordingly to the landscape that you're working with. Catmint goes without saying. We know catmint's a heat-tolerant plant for all those same reasons because of the adaptations of the leaves and the color. And so we've got various options. Catmint blooms, is a great pollinator plant, very drought tolerant. And we're getting more varieties of catmint that are out there for different uses. Little Trudy is one variety you can look for from the Plant Select program out in Colorado, and they have selected this one for smaller footprint. So it basically is more of a dwarf size. So sometimes the gardeners may be interested in some of these newer varieties that are available. Lavender is always a popular plant in a heat when we're talking about heat because it obviously originates in areas that are very hot. And so it has the adaptations. Again, it has those narrow leaves. It has a lot of the adaptations that we've already discussed that can help mitigate the heat problems. It's a great plant for pollinators. The one thing with lavender is you have to be very careful about siting this plant. It really needs to be in a very well-drained soil. And so we've got to make sure our soil is well draining around this plant. It doesn't stay too moist, especially during the fall and winter. Otherwise, it's going to be a very heat tolerant. It kind of originates in those Mediterranean areas where those temperatures are regularly over 100 degrees. So it's very well suited for hot summers if we can get it sited correctly. The one that I've enjoyed growing here the last couple of years is the Fremont's Bush Clematis. This is kind of a unique clematis variety that grows in tough environments, rocky hillsides, basically. And so it can handle heat, and it's kind of a very unique, low growing, almost a bush, as the name says. stays fairly small and compact, so that's nice for landscape use. Again, like the lavender, requires that well-drained soil, but it has those adaptations again that are going to help it survive. It has got very thick leathery leaves, a very compact growth form. It has a lot of the pubescence as well that we've seen in the other plants. Blue false indigo is a common one we recommend for landscapes. It's a heat-tolerant plant with a very deep taproot, and that's one of the adaptations you'll see in our native plants, in our native C3 plants. They develop very thick, hardy roots or plant crowns that enable them to even go dormant during heat and then return. And so they store an awful lot of energy in that root system, so that if we do get into a heat wave that causes the top of the plant may struggle, but that root system or crown has enough energy to easily regenerate when conditions improve. So that's a strategy, an adaptation these heat tolerant plants have. So this is one we recommend for that reason, because it has such a deep taproot. It's a long life. Very great plant for a pollinator garden as well. And so we point people to that one when they're interested in heat tolerance. Iris fits into that category as well because of its thick rhizomatous root system. Again, it has those storage structures that contain a lot of energy and can regenerate itself. And so once they're established, are very heat tolerant. It's got the leaf structure again that is resilient to heat. And so we've got different anywhere from dwarf irises to the typical bearded iris. We've got a lot of options we can use, but they're very heat and drought tolerant once established. And so that's a good option for our central Kansas gardeners and across the state. Salvia, this one is well known in landscapes, pretty common plant. It's a C3 plant as well, but it has those adaptations that we've already mentioned, leaf shape, some of the different storage, the rooting system. So it's got a strong ability to tolerate heat, and there's a number of varieties of the Salvia nemorosa, May Night, Marvel. Those are just a couple of the ones we've grown, but they do wonderful, and they're actually blooming right now. So it's a great plant to include in your spring for your spring blooms. Amzonia or Blue Star is one I like to highlight because it has that thick crown, that thick woody crown. And if you look at the bottom of Blue Star, what you'll see is that crown has is an energy storing. It's just an amazing dense energy storage system. And so you can see in the picture here that I grabbed, it's got an intense crown at the bottom of that. Start of that root system. And so these plants are very adaptable. And, if they go through a period of high heat that stresses out the top, they've got all this energy stored, like I said, to regenerate from. And so that's a part of their adaptation, again, to survive heat. So the blue ice Amzonia is a nice low growing variety. So if you need something shorter, that's a great one to look at. There's also the more clump forming tall varieties that can provide a little bit more of a foundation plant, maybe in the back of a bed as well. So different options there in that particular plant. Lamb's ear, again, the adaptations are there. We see the immense pubescence on the leaf, and the color of that leaf again matches those adaptations we've already described. So it has the heat tolerance. The humidity can be an issue with this one. It does sometimes struggle in high humidity with the denseness of that crown. So if you can site it where it gets some air movement, that's good. Butterfly milkweed is a fantastic plant to include. It's one of those heat tolerant, and of course, with the love for monarchs, of course, we get kind of a lot of bang for the buck with our milkweed. It's got all those adaptations. It's a C3 plant, but it's got the adaptations of the thick leaves that resist wilting, the pubescence, the waxy covering. It's got a large, deep taproot. So again, we've got all the necessary parts here to tolerate heat. And of course, it's one of the best bee plants, milkweeds that we know of, because this is just a snapshot of the variety of bees that you can find perusing your butterfly milkweed. So not just for butterflies. The common milkweed is also one, if you got more space to let it spread, the need is there for more of these stems of milkweed, obviously, with our monarch population declines that we're seeing. So we're encouraging more of this. It is a heat-tolerant plant. It's got C4-like photosynthetic efficiency. It's got that thick leaf, waxy leaf. And so it also grows as through rhizomes. And so, of course, it's got underground storage systems. So it's very resilient and returns after stressful, years, stressful summers, things like that. It can regenerate itself quite well. So it is an issue. If you don't have a lot of space, you may have to do a little work to control it. But if you've got the ability, it's a great one for our monarchs. So this kind of highlights that common milkweed. You can see underneath that leaf, if you turn it over, the pubescence again. And so as we look at these plants, start to notice some of those heat tolerant adaptations as you look at them. Coneflowers are very heat resistant as well. So the Retivida, the Echinacea, these different coneflowers are wonderful for heat. They have a number of those adaptations. You can see here again, if you've ever dug up a coneflower and seen that thick crown at the base of it, again, we've got that storage ability to regenerate from. So they do tolerate a lot of heat quite well. Rudbeckia, black-eyed Susan, we've got a number of these that we can use in our landscapes, and very heat resistant. Some of these can be a little short-lived, so you do have to be aware of that. But a wonderful plant for pollinators and for tolerating heat. Blazing Star is a fantastic one as well. Has a narrow leaf shape, kind of matches some of those adaptations that we've already mentioned. This is another plant to include with your monarch plantings. It's a highly preferred plant by monarch butterflies. So not only does it tolerate heat, but we're supporting those monarchs as well on their journey. As a side benefit, you can attract the bleeding flower moth, which is a specialist on the blazing star. So some of these plants bring along other biodiversity with them into our landscapes. Alliums are very popular for heat tolerance because they have that waxy leaf. They have that bulb system underground with a lot of fibrous roots. So they have an immense storage system of energy to grow from. And so with the leaf adaptations and the storage adaptations, that makes allium a wonderful option for summer blooms in our landscapes. A number of these are out there. There's also a native variety of the prairie onion. Lots of options. Agastaki is a fantastic heat-tolerant plant as well for pollinators. Has a little bit of adaptability to move from shade to sun, so it can go in either direction. It's got C3 photosynthesis, but a lot of adaptations that do make it heat-tolerant. Globe thistle, Echinops, this is one that can be used in a heat-tolerant garden. These are pretty unique flowers, kind of fun one to have. Attractive to the butterflies and bees, has those adaptations, as you can see with the color, as well as that deep taproot and storage system. And so a number of different ways it can tolerate those high heat events. Autumn sage comes in as a very heat-tolerant plant as well. Salvia gregii, there's a number of varieties you can look up. And we've grown this for a number of years and it's wonderfully heat-tolerant, and it blooms a lot. So it's a fun plant to have in a landscape. So it's got those small aromatic leaves. It's got a deep root system, a lot of drought tolerance, and so just has all the characteristics we'd be looking for. Blue sage is a plant that blooms closer to fall season, late summer into early fall. But this plant, as you can see, has kind of that off light green coloration as well, indicating a lot of heat tolerance. It's got small, narrow leaves, but the blooms are fantastic. The blue just stands out so wonderfully in the fall against grasses and different things we can plant it with. So this one, the blue sage, is a wonderful addition, to a pollinator garden or a landscape for that reason. The fall sunflower is a wonderful plant we can use for a lot of our landscapes have, the larger sunflowers can be a little bit tricky. This particular variety stays a little smaller, so it works well in our typical landscape settings. Goldenrod, we're going to finish up here with just a few more slides. Goldenrod, there's a lot of varieties of goldenrod, but Wichita Mountains originates in an area that is drought and difficult in southwestern Oklahoma, the Wichita Mountains. And so this particular variety is a wonderful option for heat tolerance. It has a lot of adaptations that are going to make it work wonderfully if you have a hot area to plant in. Asters, of course, are very heat tolerant. And so that kind of rounds out some of the full sun plants. Those, again, have all those same characteristics. So we do also put those in the list. Just a couple more slides here. Solomon seal is a wonderful plant for shade that has some of that heat tolerance. So if you're looking for shade, consider that one. It does typically for us do really well during hot summers as long as it's planted, sited correctly. So that's something you can look for in the shade if you're needing it. A few others for shade would be liriope. We've also got hosta varieties that are known to perform better in the heat. And so if you look for the fragrant flowering varieties of hosta, you'll see that those are better in the heat and a good choice. I've listed a few of those there. And then we've got a few others for shade, whether it's the big root geranium, woodland phlox, native sedges, columbine, and wild ginger. So those are, some final options I'll kind of leave you with. Since we're running out of time, we're going to kind of end there. But this will give at least a starting point, I think, for some of you to jump off and find some heat tolerant plants for your landscapes this summer. So with that, I'm going to say thank you for your attention. And we may have just a minute or two here for a question if anybody has any to throw at us. So.
Fantastic. Thank you so much for that, Jason. That's great information to have, especially as we get into the summer growing season. So just a few questions from chat. Thank you, everybody, for your questions. This one was from pretty early in your presentation. What should I put on my trees to protect them from the sun? You kind of mentioned doing some trunk protection, but anything leaf-wise?
Right. Yeah. No, there's tree wraps that are made out of a corrugated material that you can just wrap around those trees. You can also get tree guards made of plastic. Some of them are white that are pretty reflective of sunlight, so they're nice to shade the trunk. But yeah, either one will work. Yeah.
A great product to always put down on your trees is water.
Yes.
Often overlooked. And then we mentioned deep infrequent irrigation and letting things dry out between waterings, but what if you're using Oyas in your vegetable garden? Should you still let things dry out a bit between refilling those?
Well, yeah, no, it certainly allows those plants need to allow that oxygen kind of get back in the soil. So yeah, some dry time is not a bad thing because it does encourage those plants to seek out water with their root systems, so develop a deeper root system. So yeah, let it dry a little bit in between.
Perfect. That looks like all of the questions that we have in the Q&A for now.
Okay, fantastic.
All right. Thank you, everyone, for your questions, and thank you to Jason for that wonderful presentation. Sometimes we have more questions than we have time for, but remember all of those resources that we shared in the chat will be linked on the website when those resources are posted. If you need additional information, please feel free to contact your K-State Extension office. Those local experts will be happy to help you. Once again, thank you for joining our K-State Garden Hour series hosted by K-State Research and Extension. We are so glad you could be here today to learn about heat-loving perennials for Kansas. You can visit the K-State Garden Hour website to view our recorded Garden Hour archive or to make a tax-deductible donation to support the continuation of this webinar series. This session has been recorded and will be posted to the website by tomorrow afternoon. After this webinar ends today, you will receive a prompt to take an evaluation survey. Please fill this out. We appreciate your feedback and we do use it to improve our future webinars. If you have any other questions, please don't hesitate to reach out to us at our email address, which is gardenhour@ksu.edu. Thank you again. We hope you continue to tune in each month and have a wonderful week.